Hello and welcome to the Fossil Huntress podcast. This week we had a great question from a reader. Were the dinosaurs warm-blooded or cold-blooded? And the question's very timely. There was actually a recent interview in Scientific America with Thomas Williamson. Williamson is a delightful researcher out of the New Mexico Museum of Natural History and Science, and he studies dinosaurs full-time. One of the compelling questions he looks to answer in his research is exactly this. Were they warm-blooded or were they cold-blooded? And what does the evidence show? So as yet, there is no definitive evidence proving whether or not some dinosaurs were warm-blooded, but scientists have wrestled with this question, and it's a worthy question for some time. There is clear evidence in bone structure between modern cold-blooded and warm-blooded animals. So warm-blooded animals tend to have highly vascularized bone tissue with space in it, so not the dense tissue that we see in cold-blooded animals. And we do see a difference in dinosaur bones. So they tended to have highly vascularized or porous bone early in life, and then it gets deeper and denser, sometimes with growth rings as they reach maturity. But the evidence doesn't prove warm or cold-bloodedness. It might actually prove growth rates. So it may be that when dinosaurs were born, they were lighter and they had more vascular bone, and then as they grew older and heavier, and the rate that they grew heavier, their bones became more dense to support that body weight. Endothermy, or warm-bloodedness, is the ability to regulate body temperature, so for you and I and for animals, to use our metabolism rather than the outside temperature to keep us warm. And it's a key to survival and reproductive fitness in a world where temperatures fluctuate. If we look in modern animal communities, so out on the tundra or in forests, there are far fewer warm-blooded predators relative to prey than cold-blooded predators. And this is because warm-blooded animals are hungry. They tend to eat far more than cold-blooded animals, so a given amount of prey will support far fewer warm-blooded predators. So we can look in the fossil record for where we find dinosaurs and what we find in their bellies and what was available for them to eat, and this can help add to that evidence. Unfortunately, it's very difficult to determine the actual relative abundance of predator versus prey from the fossils because the fossil record does not always preserve an accurate representation of the original animal community, so we don't know who's who in the zoo. We can also look to the environment and where we find dinosaur fossils. So dinosaurs were able to survive at high latitudes. We find them in the fossil record in Alaska and Canada, well above the Arctic Circle. And during the time that these animals lived, the climate would have been generally warmer than it is today. And it's possible that they migrated up in the summer months and then retreated to lower latitudes during the cold polar nights. One of the clues we can look at to figure out if an animal is warm or cold-blooded is how did they move about in the world? On all fours or did they stand up? In modern warm-blooded animals, they tend to have erect or stand-up posture, like you and I. We walk on two legs standing up, versus cold-blooded animals that tend to move around on all fours. And most dinosaurs had erect postures, so it's been suggested that this may be an indicator for warm-blooded potential. And along these same lines, scientists have looked indirectly at the potential blood pressures of dinosaurs. Warm-blooded animals tend to have relatively high blood pressure, and cold-blooded animals tend to have relatively low blood pressure. And blood pressure can be estimated by looking at the vertical distance from the head to the heart. So how far is the head from the heart? When we look at a dinosaur like Brachiosaurus, so they're a genus of sauropod dinosaurs that lived in North America in the late Jurassic, so about 154 to 153 million years ago, we can guesstimate from the shape of their body, so they walked on all fours and had a really long neck, that their blood pressure would be about 500 millimeters of mercury. This figure is about 5 times higher than that of a human. And on the other hand, another dinosaur, like the ceratopsians, would have had very low blood pressure, closer to that of a living reptile, based on their body analysis. Another clue we can look to in terms of warm-blooded versus cold-blooded would be brain size. So warm-blooded animals like you and I tend to have relatively larger brains than our cold-blooded friends. So not cold-blooded friends, but the other cold-blooded animals living in the world. And brain size and larger brain size is needed to coordinate active, highly energetic animals. Most dinosaurs had very small brain sizes relative to their body size, and granted, they have very big bodies. Their brains most closely resemble the relationship of modern reptiles, so brain to body size in reptiles. A few small predatory dinosaurs have relative brain sizes that are comparable to those of some living birds, such as ostriches. In my view, the strongest evidence or clue for whether dinosaurs were warm-blooded and cold-blooded, and it's certainly possible that they are a bit of both, are birds. So birds are warm-blooded, and they evolved from a group of meat-eating dinosaurs. And so you could argue that dinosaurs, being the precursors to our modern birds, were also warm-blooded. But the court's still out, and it'll probably be a while before we know for sure whether dinosaurs were in fact warm-blooded or cold-blooded. Thanks for listening.